All right, so now, last thing, put it all together. How to graph a polynomial function. And again, we have actually done a lot of this, if not all of this, before. Now we're just putting it together. The reason why this is so important is because this is what we want from polynomials, is using the graphs to model things. That is the real world application of mathematics, is modeling stuff, or one of the real world applications. There are many. And also in further levels of mathematics, this is going to be a key part of that as well. So let's look at graphing polynomials. A couple things just to refresh our memory on. Some terminology. So zeros, factors, solutions, and intercepts. A lot of these are really the same thing, right? So we've talked about this. This is our generic polynomial function. A zero, so k, just being some number, is a zero of a polynomial function f. That is if f of x equals 0 when x is k. A factor would be x minus k. So x minus k is a factor of the polynomial f of x if, when we divide f of x by x minus k, we get a remainder of 0. A solution, so k is a solution or root, so root is another term we've heard, of the polynomial equation f of x equals 0. So if this makes the equation true, then it is a solution or a root. And then X-Intercept. So if in all of these instances k is a real number, then k is an X-Intercept. And it will show up on the graph at the point k comma 0. And so just to reiterate the first two things I said, zeros, so if f of k is 0, then it's a 0. It is also a solution or a root. And if f of x over x minus k has a remainder of 0, then x minus k is a factor. It's an k is an X-Intercept if it is a real number. All right, so let's do an example, right? Let's just get to it. So if I have f of x equals 1/6 x plus 3 times x minus 2 squared. Okay, if we want to graph this, what should we do first? Well, I would say we should find the intercepts. That would be both x-intercepts and y-intercepts. So remember, to find the x-intercepts, or the zeros or the solutions, we could use our calculator. We've looked at doing that. Another thing we could do is we can try and factor. Now, this equation is already factored for us, so that makes the problem a lot easier. So the first thing we can do is set this equal to 0. And it's already factored, so I can set each factor equal to 0. Now, notice the 2 here, this 2 is what I'm talking about, that is telling us that this factor occurs twice, and remember that means that the solution, or the 0, is going to have a multiplicity of 2. So let's go through these. Well, 1/6 doesn't equal 0, I can ignore that. X plus 3 equals 0, so x equals negative 3, and x minus 2 equals 0, so x equals 2. So my x-intercepts are going to be the point negative 3, 0, and the point 2, 0. My zeros or solutions are x equals negative 3 and x equals 2. And then to find the y-intercept, remember we actually plug in 0 for x. So f of 0 is going to be 1/6 times 0 plus 3 times 0 minus 2 squared. Negative 2 squared is 4. So this becomes 12 over 6. So I end up with f of 0 is 2, which tells me that my y-intercept is the point 0, 2. So now let's go ahead and plot our x-intercepts and our y-intercept. Okay, so I plotted my x-intercepts here. I plotted my y-intercept. Now, another thing that I have also done is I identified the degree and the leading coefficient to help me identify the end behavior. Why do I care about that? Well, remember, the whole point of this is I'm trying to graph, right? And so I can see that this is x to the first, right, the x plus 3, and then this, if I was to multiply it out because it was a multiplicity of 2, this would be x squared. So if I was to multiply all of this together, I would end up with x cubed. So the degree of this polynomial is 3. The leading coefficient is 1/6. So really what I care about is leading coefficient is positive, degree is odd. So my end behavior as x goes to negative infinity, which is to the left, f of x is also going to go to negative infinity, which is down. As x goes to positive infinity, which is to the right, f of x is also going to go to positive infinity, which is up. So why do I care about that? Well, then I know that my graph is going to look something like this. Those are supposed to be arrows on the end. And this is supposed to be a bounce, not a sharp turn. So I apologize that I made that kind of drastic. And I know that because of the multiplicity of 2. Remember, this x-intercept had a multiplicity of 2, which is even. And if we have an even multiplicity, then on the graph it has to bounce. Now, the other thing I should also do is use my calculator to help me. So I have done that. I plugged this function into my calculator. So you can see I plugged that in. I didn't multiply it out. Make sure to put parentheses around the 1/6 and each one of the factors. Also, don't forget, and I'll arrow over so you can see this, that the x minus 2 was squared, right? The entire quantity. So I made sure to square that. So you can see that. And then we hit graph. I can see good, my x-intercept, my y-intercept, other x-intercept, multiplicity of 2, so that bounces. I can see my end behavior. And if I wanted to be a little bit more accurate, I could also then look and see, okay, well, I know I have a point at -1, 3, at 3, positive 1. So I could use those to help me graph this a little bit more accurately as well. Okay, I want you to try and do this one. Graph the function. Identify the key features like we did on the previous problem as well. Pause the video. Try it on your own. All right, so here's what my graph looks like. Again, identifying the key features. Let's talk about those. So I found my x-intercepts and my zeros by setting the function equal to 0. Again, this was already factored for me. If it was not factored, then I would either need to use my calculator to help me find some zeros and then either do synthetic division with those zeros like we've done before, or maybe the calculator finds all the zeros for me, or I would need to try and factor the polynomial, potentially by grouping, or if it's a quadratic, using one of my techniques for factoring quadratics. So anyway, I set it equal to 0. 1/4 doesn't equal 0. Set each of the other factors equal to 0. I get x equals -2, 1, and 3. Remember, these would be the zeros, solutions, or roots, but they're also the same as the x-intercepts. The only difference is when I talk about x-intercepts, I usually write them as coordinate points. So the point -2, 0, 1, 0, and 3, 0. Just to reiterate, remember the y-coordinate is 0 because that is the y-coordinate on the x-axis. That is also why we literally set y equal to 0 in the equation when we're finding x-intercepts, or zeros. Okay, so those are my x-intercepts. I plotted those here in dark purple. Then I found the y-intercept. So for the y-intercept, I plug in 0 for x because, again, literally the y value on the, the x value on the y-axis is 0. So I plug in 0, do a little bit of arithmetic. I end up with 6/4, which is the same as 3/2. 3/2 is the same as 1.5. So my y-intercept is the point, 0, 1.5. And I plotted that on my y-axis. Now, just for fun, I also confirmed this on my calculator. So you can see my calculator here. And I can see on my table in the calculator, I also have the point -1, 2, and 2, -1. So to make my graph a little bit more accurate, I plotted those points as well. Before I did that, though, I also identified the degree and the leading coefficient to help me with my end behavior. So the degree is 3 because if I was to multiply all of this out, I would end up with x cubed. The leading coefficient is 1/4 because if I was to multiply all of this out, 1/4 would be the thing in front times the x cubed part. And then my end behavior, so as x goes to negative infinity, f of x also goes to negative infinity, and as x goes to positive infinity, f of x also goes to positive infinity. So I got my graph, and again, I used the calculator to help me confirm that. So again, just to reiterate, when we're talking about graphing polynomials, just use all of the previous things that we've talked about. So X-intercepts, Y-intercepts, degree, leading coefficient to help us find the end behavior, identifying multiplicity, factoring, and finding the zeros by doing synthetic division and using the calculator as well. Those are all of our techniques, and we're just kind of putting that together to help us graph a polynomial. Obviously, also use the calculator to help you with that.